When you look at the stars on a clear night, you're seeing them as they were years, even millennia ago. Light travels incredibly fast, about 300,000 kilometers per second. But space is unimaginably vast. Even the closest star's light takes over 4 years to reach us. The deeper we look into space, the further back in time we see. Telescopes are our time machines, collecting ancient light from distant galaxies. The farther we look, the earlier in the universe's history we're witnessing. It's like peering through a window into both distance and time. Light carries information, and when it finally arrives, it brings us images of what once was. Astronomers use this fact and powerful telescopes to study the early universe, star formation, and the birth of galaxies. With each new telescope, we push our time machine further back. We get closer to the beginning of everything. This is why building better telescopes is so important for understanding our cosmic origins. Every new telescope lets us see deeper into the universe's past. Two of the greatest time machines we've built are the Hubble Space Telescope and the James Webb Space Telescope. Hubble launched in 1990 and has given us breathtaking images for decades. It orbits high above Earth, revealing the universe in ways we never imagined. James Webb is the new kid on the block, bigger, colder, and able to see deeper into space and time than Hubble. Webb's launch in 2021 was a historic moment for astronomy. Both telescopes are marvels of engineering, designed to solve mysteries ground-based telescopes cannot. Hubble sees mainly visible and ultraviolet light, while Webb sees mostly infrared, the heat glow of distant, ancient objects. Together, they give us a much fuller picture of the cosmos. Like detectives, they examine clues from different parts of the light spectrum. Each adds something vital to our understanding of the universe's story. Hubble and Webb are partners in unraveling cosmic mysteries. Why not just use telescopes on Earth? Our atmosphere is both a friend and a foe. It keeps us alive, but it also blocks and blurs much of the cosmos. The atmosphere acts like a frosted window, scattering and absorbing light, especially ultraviolet and infrared. Stars twinkle because of turbulence in the atmosphere, which is a nightmare for astronomers seeking sharp images. Even the best mountaintop observatories must fight this distortion, using clever technology to compensate. But there's a limit. The atmosphere soaks up certain wavelengths of light. Infrared and ultraviolet, for example, get mostly absorbed before reaching the ground. That means ground telescopes miss out on huge chunks of information from the universe. Weather is another problem. Clouds, humidity, and pollution can block the view for days. For astronomers, these interruptions are major obstacles. To truly unlock the universe's secrets, we had to get above the clouds. In space, there's no atmosphere to blur or block the view. Telescopes in orbit get a clear, unfiltered look at the universe. This is why Hubble and Webb were launched into space, beyond the reach of weather and air. Up there, every photon of light comes directly from its source. Space telescopes can observe the entire sky, day or night, and gather data for much longer periods. Observing from space has allowed Hubble to discover new galaxies and measure the age of the universe. Webb, with its sensitive instruments, can peer further back in time than ever before. How does a telescope collect light? The answer lies in its mirrors. The bigger the mirror, the more light it gathers. Key for seeing faint, distant objects. Light from space enters the telescope and bounces off a curved mirror, focusing it to a point for analysis. Hubble's main mirror is a single piece of glass, about 2.4 meters across, polished with extreme precision. Webb's mirror is made of 18 hexagonal segments, forming a much larger surface, 6.5 meters wide. Bigger mirrors mean brighter, sharper images, letting astronomers see galaxies and stars too faint for smaller telescopes. Mirrors are the heart of any great telescope. Hubble and Webb are both space telescopes, but they were built for different purposes. Hubble orbits just 550 kilometers above Earth, while Webb is stationed 1.5 million kilometers away at L2. Hubble's design is more traditional, with a tube and a single large mirror. Webb's mirror is so big it had to be folded to fit in the rocket, and it uses a giant sunshield instead of a tube. This sunshield keeps Webb super cold, essential for its infrared vision. Hubble sees mostly visible and ultraviolet light, giving us stunning images of galaxies and planets. Webb specializes in infrared, letting it see through cosmic dust and spot objects too faint or cool for Hubble. Webb's bigger mirror and colder instruments let it spot galaxies formed just a few 100 million years after the Big Bang. Hubble was revolutionary in its time, and Webb is now pushing the boundaries even further. Each telescope opens a new window on the universe. Hubble orbits Earth every 97 minutes, moving at over 27,000 kilometers per hour. Unlike Webb, Hubble is close enough that astronauts have visited it for repairs and upgrades. Hubble carries several scientific instruments, including cameras and spectrographs, each designed to capture different wavelengths of light. Its main camera, Wide Field Camera 3, takes detailed pictures in visible and ultraviolet light. Hubble's spectrographs reveal secrets about stars, galaxies, and even exoplanet atmospheres. Its images have become icons, and its data has led to thousands of discoveries. Hubble has truly changed how we see the universe. The James Webb Space Telescope orbits a special spot called L2, where Earth and the Sun's gravity balance out. Here, Webb can keep the Sun, Earth, and Moon all on one side, making it easier to block their heat and light. Webb's instruments must be kept extremely cold, around -233 degrees Celsius, to observe faint infrared signals. To stay cold, Webb carries a tennis court-sized sunshield made of 5 thin layers, each reflecting heat away. The sunshield unfolded in space, protecting the sensitive mirrors and cameras. Without this shield, Webb couldn't function at all. Webb's location and sunshield let it spot the faintest, coldest objects in the universe. Webb's mirror was too big to launch fully open, so engineers designed it to fold up. After reaching L2, Webb began a complex process of unfolding. The sunshield opened, then the secondary mirror swung into place, followed by the main mirror segments. Each of the 18 gold-coated segments unfolded and locked into position. But just opening the mirrors wasn't enough. Every segment had to be aligned with nanometer precision. Webb's computers and motors adjusted each segment bit by bit, using light from a distant star to fine-tune the mirror shape. This process took weeks, but it was essential for sharp, clear images. The success of Webb's deployment and alignment was a triumph of engineering. Webb proved we can build and assemble a giant observatory a million miles from home. When Webb or Hubble photographs a distant galaxy, it's capturing light that started its journey billions of years ago. Because light takes time to travel, every image is a snapshot of the past. Some galaxies Webb sees are so far away that their light began crossing space before our sun even existed. By studying galaxies at different distances, astronomers can see how the universe changed over time. As the universe expands, ancient light gets stretched into longer, redder wavelengths, infrared. Webb acts like a time-lapse camera, showing us the universe's childhood and even its baby pictures. This is why astronomers are so excited about Webb and Hubble. Together, they let us rewind the universe and watch its story unfold. Hubble changed everything. It revealed that our universe is full of galaxies, hundreds of billions, not just thousands. Hubble helped measure the age of the universe and discovered that it's expanding faster and faster. Now Webb is taking us even further, seeing the first stars and galaxies and searching for the building blocks of life. We are finding things we never expected, proving the universe is more surprising than we ever dreamed. Together, Hubble and Webb have turned the sky into a cosmic archive. Their images inspire wonder, but their data change science. They help answer humanity's oldest questions. Where did we come from? How did the universe begin? Space telescopes remind us of our place in the cosmos and our ability to see deeper into the history of reality itself.